Most students lose easy marks in JAMB not because they don't know chemical equilibrium, but because they misunderstand one simple rule, which is the Chatelier Principle. In the next few minutes, I will show you how to answer any Chatelier question in exams. Recall, chemical equilibrium is the state of a chemical system in which the rate of the forward reaction equal to the rate of the backward reaction. R1 for rate of forward, and then R2 for rate of backward reaction. The Chatelier Principle states that when an external constraint is exerted on a system in equilibrium, that equilibrium position shifts so as to cancel the effect of the constraints. Now let's keep it simple by applying it to some questions. Now to the first question, where we get to apply the Chatelier Principle. In the above reaction, forward reaction is favored by. Now this question wants us to identify the external constraint that will cause equilibrium to favor the forward reaction. So this arrow here represents our reversible arrow, where this is our forward and this is our backward. So we've been given extra information here that this reaction is what? Endothermic. That is, this reaction absorbs heat from the environment in order to commence. So if the forward reaction is automatically endothermic, means our external constraint should be to supply heat to the chemical system so that equilibrium can shift to absorb the heat we are supplying to the system. So, which implies that the correct answer would be increasing the temperature of the system. Now the next question. When at equilibrium, which of the reactions below shift to the right if the pressure is increased and temperature is kept constant? Now we're looking at the external constraints being increase or decrease in pressure. So the question implies that you should find the equation where an increase in pressure will cause the equilibrium position to shift to the right. That is, equilibrium will favor a forward reaction. Now the conditions for pressure to be able to influence equilibrium position starts with 1. The number of molecules on the reactant side should not be equal to the number of molecules of gases on the product side. Yeah, it is important to note that pressure affects only gases, only gaseous molecules in the chemical system. So the number of moles on the reactant side should not be equal to number of moles product side. Number of moles on product side. 2. And the second condition is that it affects only gases. Now, the side with the highest number of moles would experience high pressure. So, while the side with the lowest number of moles will experience what? Low pressure. Let's take this for example. There are 3 moles of gases on this side, that is 2 plus 1. While here we have just 2 moles of gases. So this side experiences high pressure, while this side is automatically experiencing low pressure. So if this chemical system experiences high pressure, that is, the external constraint exerted on the system is high pressure, equilibrium position will shift to the right, favor low pressure. And I think that reflects what the question wants again. Let's take the question again. Which of the reactions below shift to the right if the pressure is increased? Okay, so without even going too far, the first option answers this question. That if we increase the pressure on this system, equilibrium will shift to where there is low pressure, which is pointing to the what? to the right. So our answer is this one right here. On to the next question. What happens to the reaction above when the hydrogen ion concentration is increased? So we're looking at a situation where the external constraint is increasing the concentration of this hydrogen ion. According to the Chatelier Principle, once again, equilibrium shifts to cancel out the effect of increasing this concentration. The equilibrium will favor a reaction that consumes the increased concentration of the hydrogen ion by favoring the backward reaction, because the backward reaction will consume the increased amount of hydrogen ion in the system. So equilibrium position will shift to the left, and this is your answer right here. So I believe with how we've applied it, let us attempt this question. You can put your answer in the comment section. For this system, if the pressure of this system is increased, so the external constraint is increase in pressure. If the external constraint is increase in pressure, put it in the comment section. Where do you think equilibrium position will shift to? Where do you think equilibrium position will shift to if the external constraint on this system is increase in pressure? Yeah. If you enjoy this session, please like, subscribe, and